Hello, our next problem is largest sum contiguous subarray. So what we want to do is we are given an array, okay? We are given an array and we need to find what is the largest sum of the contiguous elements in that very array. So in input we have something like this array 1 1 2 minus 2 minus 4 5 3 minus 1. So we need to find out, for example, here out should be 8, right? These two elements conjugate into maximum sum. Okay, so we have a couple of algorithms for this problem. First one is Cadac's algorithm. So we'll see what is it. So what is said is to have a couple of integers or variables which we need to initialize. First step is have overall maximum, overall max, and which I'll initialize to 0, and another is current max. Okay, current max, which I'll also initialize to 0. So what is our next step? We will go through complete array. Okay, traverse through array with the help of for loop. Okay, with the help of for loop we'll go through the array and we'll update our overall max and current max. So our current max will update first. Current max will become current max plus AI current element. We will add that current element and check whether this current max has gone below 0 or not. Okay, if this thing has gone below 0, then we'll update this current max to 0 again. Okay, and we also will check if current max becomes greater than overall max, then what we'll do is we'll update overall max to current max. Okay, we'll update this thing, and at the end of this loop, third step will return overall max. Okay, so we'll check how this algorithm works with the help of an example. Okay, so let's consider the array 1 1 2 minus 2 minus 4 5 3 and minus 1. So we'll have a couple of things, overall max and current max. Okay, initially both are 0, so it goes to the first element, it updates it to 1 and checks whether this is less than 0. It is not less than 0. Checks whether this current, it updates its overall max is currently 0. So it starts with updating current max, and current max becomes 1, 0 plus AI, so it becomes 1, and checks whether this is greater than 0 or not. It is greater than 0, so it goes to the next step and checks whether it's greater than overall max or not. It is greater than overall max, so it updates overall max to current max, that is 1. So next step we go, it adds one more, so current max becomes 2, and this is greater than 0 as well as greater than overall max, so overall max also gets updated. Okay, this becomes 2. Next step is it goes to next element, it becomes 4, this is greater than 0, it again greater than overall max, so it updates overall max to 4. Next step is it becomes 2, so it is greater than 0 but it is not greater than overall max remains 4. Next step, or this current thing becomes minus 2, it is less than 0, so this thing gets updated to 0, and currently also overall max is greater than current max, so it remains 4. Next step is it gets updated to 5, correct? And this thing is greater than 0 as well as greater than overall max, so overall max gets updated to 5. Similarly, next step, it becomes 8, this is greater than 0 as well as greater than overall max, so this becomes 8. Next step, this becomes 7, greater than 0 but not greater than overall max, this becomes 8. So we at last we return overall max, that is 8, correct? Okay. So if you check, this algorithm doesn't handle a case in which all the elements are negative. If all the elements are negative, clearly it returns 0 as an output, which is incorrect. So if all the elements are negative, we can handle a case with some algorithm which finds out the minimum element in this array and returns that as an output. So there's one other method with the help of which you can solve this problem with the help of dynamic programming. So what you'll do is we'll initialize the overall max, and I will represent it as OM and current max as CM. So both can be initialized to A0, and we can go through complete array from 1 to size. We'll traverse through the whole array. Okay, we'll traverse here, and what we'll do is we'll update current max as max of current element and plus A0, okay, and we'll update our overall max as the max of current max and overall max. Okay, we'll update it with the help of this statement, and at last we'll return overall max. So this case, if you see, it handles the case in which all the elements are negative also. So we'll see a quick example and we'll finish that. So let us consider a case -1, -2, -3. So there are two things. One is overall max, another is current max. Initially both are -1, -1 because it initialized to my A0. We start from the first element, this becomes -2. We compare it with -1. We compare with max of -1 and -1 plus -2, that is -3. Sorry, -2 and -1 plus -2, -3. So which one is minimum? Clearly -2 is minimum, so this gets updated to -2, and we'll check which overall max is minimum, so this remains -1. Again we get we've tried to find out minimum of -3 and -3 plus -2, that is -5. So max of -3 and -5 is -3, and again between overall max and current max, all max is greater, so it remains -1 and it returns -1 as its output. Okay, so that's it with this problem. Thank you.